All right, I'm gonna do this in one take. So if I get tongue-tied or if I start coughing as I want to do sometimes, I apologize. So I'm gonna start off with a demonstration of what my circuit does. What I have here is a speed control. I originally set out to build like a mock-up of a cruise control for a car. I want to do that with a potentiometer that would, increase speed, decrease speed, then you can save the speed and it would continue at that same speed, but the potentiometer proved to be really finicky. So I scrapped that. In my circuit, I have display, obviously. I have a keypad. I use switch interrupts, and then I'm also using a timer. So I'm gonna get in here real close so you can see it. So my display right now is moving. What you see is the letter 1 around the display, and that's an indication of the speed. So I'm going to go through. I'm going to step the speed up. So I'm going to increment it. Sorry, that's not an increment. That's a decrement. So that slowed it down, stopped it, and it showed it as a 0. So now I'm going to speed it back up, and then it'll go to 2. It'll go to 3, 4, 5, 6, 7, 8, 9, and it gets really blurry at this point sometimes, and then a hex A is the maximum speed. Now, I'm going to step you back down so you can see it a little better. So I can also, with this keypad, jump directly between levels. So I'm going to jump from 3 to 4, and then I can jump from 4 directly to 9, and then I can jump from 9 directly to 1, and say from 1 to 5. And that is that's the gist of what this does. At this current moment, it does not serve any practical use. Simply the display is showing the cycle time of code that I'll show you here in just a second that is based on a timer. So first off, I took everything that is not specific to the operation of my code function-wise and stuck it in my driver.h file. That includes just the giant body of the font table, different pin modes. They were there originally, interrupt enables, digital write, there's a delay function, a digital read, a pin toggle, my system timer function that gets called quite often, clear, and then all of the various display functions for set cursor, the initialization, command write, data write, the put char, and then the keypad decoder. Those are all in my driver file so that I can keep my main file clear. Because at one point, before I did all that, I was up to 800 or 900 lines of code. It was just getting really messy, so I moved it all to my driver file. So the flow of my code is that I have the system timer going, and the system timer is controlled by this timer period variable here. And what the system timer does is it's going to count up to whatever this variable is, and then then a system tick is going to occur. And then whenever that system tick occurs in this system tick handler here, this is what actually changes the display on the screen. What I have is I've got logic that starts off with an initial X and Y value for what the cursor is set at. And while the cursor is at a specific location on the screen, so this block here, which is less than or equal to 78 and greater than or equal to 0, that's the top of the screen. And then this block below it, that's the left side of the screen, and then that's the bottom of the screen. and then that's the right side of the screen. So every time a system tick handler occurs, or a system tick occurs, it will jump into the system tick handler, and then it will go into whichever of these logic blocks is true at the time. And then it will update a timer period, which is the timer period divided by an adjustment variable, which I'll get to. And then that decides on what the output is going to look like on the screen. So then it will set the cursor to whatever the current X and Y is, and then it will change either the X or Y. In this case, it's going to decrement the X. It's going to move it to the left on the screen 6 pixels, and then it is going to draw whatever it's supposed to be drawing in this case. And then right here I have a buzzer. I was going to use the buzzer in case the screen didn't show up very well, but it it showed up just fine. So that's how I'm getting something onto the screen. Practical use for this is that you could pull all of this code out and then still have it doing some kind of a transition every time the system tick goes off. So for instance, if I wanted to send out a voltage on some port to a base junction transistor that's an on-off switch for some kind of a motor circuit or anything like that, I could do that. And by manipulating this timer period, which is the initial timer period, and then this timer adjustment, you can change how quickly it will cycle. The actual adjustments occur in this port 1 handler. So there's my interrupt flag for my port 1 handler, my debounce that doesn't seem to work sometimes, and I'll get to that, and then a clear, and then this logic block here provides a minimum amount of button clicks on the low end, so that serves to give constraints to the maximum speed. And then this is my switch 2. Sorry, no, this is going to increment it. This is going to make it slower. So it takes that timer period and then it increases it by whatever my timer adjustment value is. And then it takes the counter and decreases it by 1. So it decreases the counter closer to 0 as it gets slower. And then for my switch 2, that will speed it up. And then this also gives it a maximum speed. So that increases the counter so that as the speed goes up, the number on the screen goes up as well. And then this will decrease the timer period. So it ranges from 5 million on the minimum to 15 million on the top. So when it's at 5 million, the timer counts to 5 million, and then a tick goes off, and then it starts over. And then in each of these bodies, after it updates the timer period, it will reinitialize the system timer, and then it will continue on with that new timer period. My original display that I made like this was a function that simply would start in the upper right corner, and then it would move around the screen. And while that function was going off, nothing else would occur. I could change speed, but the speed wouldn't update until after the function had gone through. So it would go through, and then it would change speed after. The beauty of the system timer is that this will occur whenever a system tick goes off, and it happens independently of anything else. So I can actively change the speed on these. Now I'm going to take this read switch and I'm going to turn on a buzzer. So I can actively change the speed independently of the system timer. So I'm not going to stop it from going off. And that's very handy because you can do multiple things at the same time. The code that I have here for my port 3 handler, which is part of the keypad, this was actually really tricky code to make work. So I have, if the key is A, which is my maximum speed, What it does is it goes through and it does the proper math to determine how much the timer period needs to be adjusted in order to jump from one speed level to another. And I found for some reason it did not like jumping directly from 0 to 10 and from 10 to 0. So you'll see some of these, they'll just change the timer period in one chunk. Whereas for the 10 block and 0, I have a for loop that runs based on the difference between the acceleration counter, which is the number of button clicks, and then whatever you're jumping to. So it runs that for loop that many times and then updates the timer period and then reinitializes the system timer each time. That may not be the best way to do it, but that's how I found worked. So that's the code that makes my keypad work. So, you know, to kind of reiterate the different things that are in my circuit and in my project, I have the display, and then obviously the timer, as I talked about, which makes the display change. And then I'm simply using interrupts, switch interrupts here to change the speed. I'm gonna hit the read switch again. So switch interrupts, and then the interrupt goes off. In my port 1 handler and changes the speed. That is how that works. And I'm gonna take just a quick second and make sure that I haven't missed anything on this requirement for the video. Okay, looks like I've hit everything that I needed to on the video. I hope this is not too long, but I had fun doing this. I learned a lot about the iterative development process, and I hope you guys did too. Thanks.